Hello, this is the Unapproachable Sudoku for the 1st of April 2024. It is a set of 3 killer Sudokus actually. 0 to 8 killer Sudoku, 1 to 9 killer Sudoku, and 2 to 10 killer Sudoku. They're actually all killer Sudokus. Wait a minute. Wait a minute. Wait a minute. Wait a minute. Hold on. They're the same killer Sudoku, aren't they? They are the exact same. Oh my gosh. Fine, I only solve one of them. Well, should I solve all 3? There's no way I'm gonna solve all 3. But alright, fine. I'll solve them for you. We'll do the special one. We'll do the 0 to 8. And at the very end, I'll explain why they're all basically the same. I'll show you the Sudokus first. If you want to just like try and figure it out yourself, these are all the exact same Sudoku. But alright, so let's take a look at the rules. Place digits 0 to 8 in each box, row, and column once each. Each cage must sum to the given total and must not repeat. So, normal Sudokus apply, meaning, almost, meaning place the digits 0 to 8 in every row, every column, and every 3x3 box. Okay. Each cage must sum the given total and must not repeat, so digits in those 3 cages, for example, sum to 8, in those 2 cells sum to 6, in those 2 cells sum to 9, and so on for every cage here. And those are all the rules. So, with that, let's just start solving. Now, interestingly, I think this is actually not very trivial, but we can look at the one with a lot of small values, like this. Lots of small values here. And there is a way to resolve them. Those digits, for example, those digits are extremely small. In fact, those digits sum to exactly 6. And for 4 digits sum to 6 is actually really weird. However, in 0 to 8 Sudoku, it is possible with 0, 1, 2, and 3. And in fact, those are the smallest digits you can place that are non-repeating, and so they must be 0, 1, 2, and 3. This 4, as a result, that digit must be at least a 4. And in fact, because it is at least a 4, that is the maximum it can be. It can't be any higher than a 4, because that digit can't be negative to make them sum to a 4. So that digit is exactly a 4, meaning that digit would have to be a 0. Can you tell that's a 0? Whatever it is, I'll just put it 9. There you go. Alright, and now with this 0 over here, that digit is no longer having a 0, so it can't have a 3 in it either, because 0 needs a 3 beside it. So it's a... What am I doing? This is a 1, 2. This is a 0, 3. This one, as a result, I think that digit is... Well, since 0, 1, 2, and 4 are already all used here, that digit must just be a 3 at least, and can't be any bigger than 3 because they sum to 3 over here. So that must be a 3, meaning that digit must sum to 0, must be a 0 to make 3 in total. 0 over here means those digits do not contain a 0 in them, and therefore we can treat it as if it were regular Sudoku. For 2 digits sum to 4 in regular Sudoku without a 0, it has to be 1, 3. This 3 over here resolves that, so this is a 1, that's a 3. Can we figure this one out? Possibly. Like this 5 cage over here with a 0, well, it can't have a 0 in it, but it also can't have a 3 in it. So in fact, it can't be 0, 5, it can't be 2, 3. It must therefore be 1, 4. So there you go. However, the 1 over here means that can't be a 1, so that's a 4. Meaning that's a 1. Okay. Nice. Alright, how do we continue with this? I love that we made a question mark with the digits so far. That digit then, I think is at least a 6, right? Yeah, in fact, because those digits are... Oh, no, it's at least a 5. Because those digits are the digits from 0 to 4, that is at least a 5. So it's either 5, 6, or 7. However, note that that digit cannot be a 0 because of this, and it can't be a 1 because of this. And therefore, this must just be a 2 at least, which is... it forces this to be as low as possible. And in fact, because if you take the minimum of both of these, you get exactly 7. So it must in fact be the minimum of 2 and 5. Cool. Okay. Hope no one's brain is starting to hurt yet. However, if we just keep looking, those digits might seem a little bit more special. I love it when it's April Fool's and I troll myself. I can't actually tell. That's a 1, right? That's a 2, that's a 5. Actually 10 and 0 to 8 because Sudoku makes 10 a bit more restricted. Because you only really have 3 options here. It's either 2, 8, 3, 7 or 4, 6. However, 3, 7 is not available. 2, 8 is not available. And this would be 5. This would be a 1. Alright, fine. I guess this... Yeah. So 3, 7 not available. 2, 8 not available. This must just be 4, 6 then. Meaning those digits must therefore be 8 and 1 to finish the box. No, 8, 5 to finish the box. And that digit, being in 7, being in a 7 cage cannot be an 8. So that is a... Oh, that's not 5, is it? It's not 5. This isn't 5, 8. This is 8 with something else. What do we not have here? 1, 2, 3, 4, 5, 6. Oh, we don't have a 7, 8. Ah, there you go. Alright, so similarly, this must be a 7, 8. That digit cannot be an 8 because it's in a 7 cage, so it must be a 7. That must be an 8. That digit is therefore a 0 because it cannot be a 7. Because the other side is already a 7. Cool. Now, where does 2 go in this box? Right, because 2 is in one of those cells. None of those cells are 2. 2 here also can't be in that cell, so 2 must go here. That's a 4, isn't it? So that resolves this 4, 6 pair. That's a 0, 3, which we can't resolve yet. But this 0 does resolve that for us. So that must be a 3, that's a 0. 0 by 0, I mean 0. Where does 5 go in this box? 5 must go there. So the remaining digits here would be, I think 4, 6, and 8. No, 6, 7, and 8. Yes. 4 is already here. Okay. Should I be really, really dumb? Yeah, let's just be really, really dumb. There you go. Oh, we're doing this. Yes, yes, yes. Yes, we're doing this. Oh yeah, okay. Let's go. Now. 12 is only made with 2 options, either 4, 8 or 5, 7. Because 3, 9 is not available. This cannot be 5, 7 though, because 5 is already in that in the row. So this must be 4, 8. So it must be 4, 8. Those 3 digits are therefore 5, 6, and 1. There you go, 1, 5, 6. 13 is also pretty constrained. They can't have a 1 in it because that can't be a 12. This 5 needs to be with 8. While... while 6 would need to be with 7. Okay, same for this actually. And 13 does only have 2 options, either 5, 8 or 6, 7. But can we figure out which one is not? Well, this is a 4, 8, isn't it? So this can't be 5, 8. This must be 6, 7. So that must just be an 8. That must therefore just... No, that's a 5 because... Yeah, sorry. This is a 5, 8. Wait, no, this is a 6, 7. Oh my goodness, this is 6, 7. This is 4, 8. This is therefore a 5, which is paired with a 7. Which is paired with an 8 to make 18. There you go. So none of those digits are 5 anymore. 1 here means those sum to 5, which could be possible with a 7, 8. Yeah, so that could be a 1. Or it could be a 6 as well, that's possible, yeah. Those digits, do we have anywhere to go? They can't be 4, 3. They can't be 1, 6 either, so must they just be 2, 5? I think they must just be 2, 5. Whoa, is this a 2 or is this a 1? Uh-oh. That's a 2, isn't it? That's a 2, I'm sorry, this is a 2. This can't be 2, 5, it can't be 3, 4, so it must be a 1, 6. No, not 2, 6, 1, 6. There you go. So that's not a 6 actually, that's just a 7. And those are not 7 therefore. Cool, actually we have pairs here as well, I think. I don't actually know what digits we're missing from here, but it looks like we're missing 7 and 8 in this column. And in this column we are missing 4 and 6. No, we're not missing a 4. We would be missing instead a 5. There you go. Okay. I love the chaos. Those form a triple. What triple do they form? They must contain a 3. They must contain a 0. They must contain a 5. There we go. Those are the missing digits. We can't remove anything from anywhere just yet. Interesting color palette though. Alright, 12 has only 2 options again. It's either 8, 4 or 5, 7. But because of this 8 over here, it can't be 8, 4. So it must be 5, 7. So that can't be a 5 anymore. It means 5 must go here. Cool. 5 here resolves this remaining pair, which gives us more stuff to work with. That would be, I don't know what that would be. Is that that's a 7. Right. Blue, or 0 I mean, not blue. I don't see anything to do with that just yet. Alright, let's keep moving. We can probably do more with here, like 0 has to be in here somewhere. I can't really tell where though. What's that? It's a 5. 5 can't be here. 5 has to be one of those cells, but I don't think we can figure out where they go yet. What is that? It's a 6. 6 is one of those cells. Not much else to work with. 0 is one of those cells. Actually, can we figure this one out? How many options do we have here? We have a lot less, I think. We have 8, 1, 2, 7. Oh, we still have a lot. Yeah, we have 1, 8. This is just like regular Sudoku. Right? Yeah, because you can't do 0 and 9. So this is 1, 8, 2, 7, 3, 6, or 4, 5. Can't be 4, 5. Oh, this is a 0. Oh, so can't be a 4, 5. Oh, I guess because of this, it cannot be a 6, 3 or a 1, 8 either. So it must be 2, 7 then. Cool. Forms an X-wings in 2s. Okay. So now 3 must be in that cell. And so the remaining digits in here have to be 8, 4, and 1. That digit can no longer be 4, so it must be a... so this digit can be an 8. So that digit must be the 8. That's therefore a 6. Oh, this is not missing a 1. Sorry, this is actually missing a 0. So that digit would now be a 2, giving us another triple over here, which has to contain 6, 4, 1. That can't be a 6. Yeah, that's it. That's most of what I can do in this triple over here. This one over here does pair with this though. Like this can't be a 1 because that can't be a 10. This, if we have a 4 here, must be paired with 7, while 6 must be paired with 5. And this can resolve that, so it must be a 7, which must be paired with 4. So that must be a 1, so that must be a 6. Cool. This 4 resolves this 4-8 pair, which does something, I would assume. That's a 7, so 13 might be constrained. Yeah, because this is no longer 6, 7, so it must be 5, 8. 5, 8. 5, 8. Can't resolve yet. But that could probably help with the 9. Because it can't be 4, 5 or 1, 8. It can't be 2, 7, so it must be 3, 6. And this can resolve that for us. This 3 resolves this 0, 3 pair. And that pair matches perfectly made a full column, so that works. The triple over here has to be 0, 1, and 2. Wow, okay. Smallest digits here. That can't be a 1, that can't be a 0. That we don't know yet. Although I guess if this is 0, that'll have to be a 6. Which doesn't work, so it can't be a 0 here. Meaning 0 must be here. If this is 1, it must be next to 5, which doesn't work because 5 is already in the box. So it must be a 2 next to a 4. Which does work, thankfully. Those digits are now... what are those digits? Those have to be 0 and 1. 0 here must have 9, so it doesn't work, so it must be 1 paired with an 8. That digit is therefore a 0. This 8 over here removes 8 from that cell. And this also resolves this 5-8 pair. That forms a pair over here, which has to be, I think, 2 and 6. Right, and we start doing an X-wing over here. There's an X-wing over here, so that can't be 2. And the way to think about it is that in this column where there's 2 go, it can't be in those cells because 2 already form pairs here. This cell can't be 2 because of... Well, this cell can't be 2 because of this, firstly. But it also resolves this, which puts a 2 over here. So that can't be 2 either, meaning 2 in this column can only go here. So this must be a 6, which means that is no longer a 6, meaning that is a 6, meaning that is not a 6, so that's a 2, meaning that is a 6. Cool. All resolvable. That can't be a 0. This cannot be a 2 anymore, so it must be just a 1. And those digits form a pair. Firstly, this 6 resolves the 6-7 pair. I didn't see that. And that has to be 3 and 2. This 2 resolves that. Okay. I think using grays was a really bad idea, but this is the only palette I had on hand right now. The other palettes are way worse if you want to look at them. This can't be a 6, so that must be a 6, meaning this is a 5. We could probably look at those digits that sum to 8, because if that is a 2, those digits must sum to a 6. And can't be a 2-4 anymore, so it can only be a 1-5. This 5 over here resolves that for us. So this is 1, 2, and 5, which do sum to 8. This 8 over here resolves this 7-8 pair. Wrong way. Okay, which means you only have pairs here to work with. This has to be a 4-7, which something happens here. This has to be, let me think about it, 0 and 3. 0, 3. Okay, and we're finally, we're almost done. We just have some stuff here to do. Actually, those sum to 10, right? Can we figure that out? Maybe. Let's do the triples here first, though. This has to be 4, 7, and 1. Yeah, in fact, the only place... Yeah, that's actually... This can't be 1, firstly. But this must also be 7, because the only place 7 can go in this column is here, because 7, because of this, can't be here. So this can't be 7, meaning that... that forms... That digit is either an 8 or a 4. This 4 resolves that for us. So that is now an 8. Sorry, that's not... Yeah, that's not... This is an 8. That's a 4. Meaning that's a 0. Meaning that's an 8. And this should resolve the rest of it for us. That must be a 3. That must be a 0. That 4. This should resolve this final section over here, which has to be 3 and 5, I think. Uh-oh. Uh-oh, I messed up. I messed up. I messed up somewhere. Alright, back to, like, being normal here. I'm not gonna lie, I really cannot do that. I don't know why I did this in the first place. What? This is 3 and 5 by the box, right? Did I mess up somewhere else? I probably did, didn't I? This resolves this firstly. That resolves this. Which resolves this. But that... Oh, this is wrong. Oh no, this is all wrong. Uh-oh. Okay, well... Should be a simple switch though. Should really be a simple switch. I might as well just turn this all back into regular digits and figure out where I went wrong here. The joke's over. But we can probably just do this. This has to be 1. I was going to do this at n anyway. This has to be 2. That has to be 3. 3 in the corner. Nice. This has to be 4. This has to be 5. This has to be 6. This has to be 7. This has to be 0. And this has to be 8. So, what went wrong here? Which cages are incorrect right now? This would have to be 1, 4, which definitely do not cause it sum to 16, so definitely there's something wrong there. Every single other cage does seem to work out though, so I'm pretty sure it's really just a Sudoku error. What is this? This is like 1, 4, but this can't be 1 or 4. I really messed up here, didn't I? I don't know what I was going for, but this is absolutely incorrect. This does not work. Alright. Cool! Can we do the 1-9 killer to see if we can figure this out properly? Let's do the 1-9 killer figure, see if we can figure this out properly, shall we? I love that I wasted all your time by doing colors here. This is an awesome April Fool's joke. Right, let's do the 1-9, figure this out. And the reason why, actually, just to actually learn stuff here, the reason why I said that these were all identical puzzles is because, I mean, okay, look at it. These cages are all exactly 2 off from all of these cages. 3, 4, 3, 4, 5, 3, 5, 6, 5, 6, 7, 5. So they're all 2 off. And what that means is that from 0 to 8, from 0 to 8 to 0 to 1 to 9, all you need to do is just to put in the exact same solution, add 1 to every digit, and every cage will be also fulfilled. Because you're adding 1 on each digit. And for these, you can add 3. So from the 8 here, it becomes an 11. And the way to do it, you just add 1 to every digit here. And it will become a 1-9 killer Sudoku. It will also satisfy everything here. And the same for 210. Every cage is increased by 4. By the number of cells that there are. So they are the identical Sudokus right here, essentially. And I think the joke here, which is frankly pretty genius, is that it looks like different Sudokus, which makes you think that you would want to solve them all one by one. The goal solve times are also like really high, just to make you think that they're all different in some way. But no, they're all completely identical, which is why I wanted to use this to actually help us solve this puzzle, which I accidentally messed up by playing with the colors somewhere. But okay, let's actually do some regular Sudoku here, shall we? We can go by regular values over here. This has to be 1, 2, 3, and 4. That is therefore at least a 5, meaning that's a 1. This cannot be a 1, 4, therefore that can't be a 2, 3. This must therefore be a, well, it can't be a 1, 4, so it must, well, it can't be a 2, 3, because 2 and 3 means that can't be a 3, so it must be a 1, 4. This one resolves that. Right, brain is trying to brain here. This cannot be a 1, 5 because of the one reading in the box, so this must be a 2, 4. 4 here resolves that. This cannot be a 1, 6 or a 2, 5. It must be a 3, or it can't be a 1, 6 or a 3, 4. It must be a 2, 5. 2 resolves that. This now we can probably resolve because it can no longer be a 1, 8. It can no longer be a 1, 8, 4, 5, or 2, 7. It must therefore be a 3, 6. 3 here resolves that. Those digits, therefore, to make 12, you either use 3, 9, 4, 8, or 5, 7. You can't use 4, 8, or 3, 9, so it must be a 5, 7. 5 resolves that. Those digits must therefore be 8 and 9. This digit cannot be a 9 anymore because that will force it to be a 0, which is not allowed in 1-9 killer Sudoku. So this must be an 8, meaning that must be a 1, therefore this is a 9. 1 here resolves as 1, 4 pair. Okay, so what now? 3 in this box must be here by Sudoku. 6 must therefore be here by Sudoku. Those digits are therefore 7, 8, and 9 by Sudoku. Those digits have to be 8 and 9. Those digits have to be 6 and 7. Okay. Let's keep going. 15s are pretty interesting. This 15 cannot be a 6, 9 in fact because of the 6 and the 9 here. So it must be a 7 and 8. Meaning this must be a 6, 9. Nice. Because it can't be 7, 8 anymore. This can't be a 8, 5 to make 14. So it must... it can't be a 8, 6 to make 14, I'm sorry. So it must be a 5, 9. That resolves the 6, 9 pair over here. This must be a 6, that must be a 9. Those digits are therefore 3 and 7 to finish the row. And I am not sorry at all for going fast here. That can't be a 9. In fact, I might go really, really slow as well just because I'm sucking at this like quite a lot right now. This can't be a 5, 9 anymore, so it must be a 6, 8. 6 resolves that. 8, 6. 13 over here cannot be. Well, it can't be 6, 7, but it could still be a 4, 9 or a 5, 8, right? Yeah. This cannot be 8, so that can't be 5. This can't be 4, that can't be 9, as expected. Okay. This must be 19, that's pretty high. 7 resolves is 7, 8 pair. This must be a 15, but can't be 8 or 7, so it must be 6, 9. Nice. Therefore, that must be an 8, which means this must be 5. Those digits must sum to 11, but can't use 5, 6, 3, 8, or 2, 9, so it must be 4, 7. 7 here resolves that. Those digits must add to 8, but cannot be... It can't be 2, 6, or 1, 7, so it must be 3, 5, I'm pretty sure. 5 here resolves that. 5 here also resolves this 5, 9 pair. Those digits must therefore be 1 and 2. 1 can't be in the 11 cage, so this must be a 1, that must be a 2, this must be a 9. That resolves the 6, 9 pair. 1 resolves this... Oh, it resolves nothing, but this 7 resolves this 6, 7 pair. 9 resolves this 8, 9 pair. Those digits must therefore be 3 and 7 to finish the row. 7 here requires us to be 1, 3 to make 11, which doesn't work because of the 1 already in the box. In the row, in the column, sorry. So that must be 3, meaning that must be 7, which resolves this. That can't be an 8. 3 here resolves this 2, 3 pair as well. That forms a triple here. Another 3 in the corner. I wonder if they all have 3 in the corners. Oh, they don't. They don't all have 3 in the corners. No, the 2 to 10 doesn't. Okay. So this is a 2, 5, 8. This has to be 1, 4, 6. That can't be 1. And these must sum to 8. So it can't be a 4, it must be 6 with a 2. Okay, we got that. Therefore, this can't be a 3, 6. It can't be a 4, 5. Could it be a 2, 7? Yes, it could. Sudoku. This has to be 3, 4, 7, right? Those can't be 7, so 7 must go there. This must be 3, 4. Those digits are therefore 1, 2. 1 resolves this. In fact, the 3 also resolves this 3, 4 pair. This therefore has to be a 4 to finish the column. 7 here means that it's not a 7, giving us a classic chocolate teapot. Every single place, every single Sudoku has that now. 6, 7, 5. So this can't be 5, 6, 4, 7. It could still be 2, 9, or 3, 8. Unless it couldn't be. Don't know why it couldn't be though. This has to be 1, 2, and 3. Oh, chocolate teapot again. How awesome. Okay. This has to be 4, 6, 9. This has to be 2, 5, 8. That can't be a 2. This has to sum to 12 because that sums to 7. So this can't be a 9 or a 6, it must be a 4, which means must make it 8. So that's a 5, that's 2. Now those cells can be 4. 8 here resolves the remaining 5, 8 pair. 4 also resolves this 1, 4 pair. This 6, 9 over here means that must be 9, that must be 6. That gives us a bunch of triples in the center. This has to be 4, 7, 9. We're going a completely different path now. This can't be 4, so this must be 4. 7, 9 can be resolved by this 9 over here, so that's 7. That's 9. Oh, it's not 4, 7, 9. 4 is still here though, but this is not 4, 7, 9. This has to be 4, 7, 8. And this 8 resolves that, so there you go. This has to be 9, this has to be 7, this has to be 8. This has to be 1, 5, 9. This can't be 1 or 5, so that's 9. 5 here remains. This 5 resolves this, which does give us that. Those just have to be 2, 3, 2, 3, 6. Sorry. This... Does this resolve? Yeah, this one resolves this over here, which gives us that. Which gives us that. This must not be a 6, therefore this must be a 2003. Solved. Nice. Never solved this, but alright, we solved this in like what? I don't know how long we took to solve this. We took pretty long as well, actually. Oh my god, sum to 40, 405. Awesome. But there you go. Hope you enjoyed this puzzle. I don't know what I'm doing over here. But yeah, I hope the colors have been decent for you. This is like honestly a failed April Fool's joke. I did want to. I did at some point want to solve a coloring puzzle for a puzzle that isn't actually a coloring puzzle. As you can see here, my lack of any skill whatsoever have completely caused me to absolutely fail this. But yeah, hopefully, you know, hopefully I didn't mess up. I mean, all the digits, yeah, you can tell here, this 6-1 and this 8-1 over here are already very wrong. But, okay. So yeah, I hope you enjoyed this video. I'll see you guys next time. Bye bye.